Look at that guy.
All right. We're live.
Oh, yes. Oh, yes, we are.
I'm happy today, Hannes, because
Okay.
yes,
How are you doing?
I'm doing great. I'm so happy to have Hannes and Alphonse with me in this adventure here. Sam, who is Alphonse actually in the Lord of the Rings analogy? If you're Sam, who is Alphonse?
Gondor comes for AIDS or something like that.
Okay,
right?
let's figure that out during the stream. Yesterday was a great day when I was prototyping, but supported with theory. So Jasper Brookman is teaching me a design process that I'm relearning that I tried to learn like 2 years ago, and my brain is toast from trying to take this disciplined way of working in to my work days. But it's fun also. It's really fun. Today, I'm going to treat myself to some prototyping. We're going to do some CADing because we had some great information yesterday. We answered 2 questions. The first question we answered is how close to the resonator the vibraphone bars needs to be. And we figured out 11 millimeters is the sweet spot. That became a true design requirement. So that was fun. And then we also prototyped these flaps. Do we have a close-up? Wide, perhaps?
Let's go to the wide. There we go.
So we had a flap here, and we tried a deeper position in the pipe to make sure that the flap isn't protruding above the surface. And we figured out, and then we tried a more shallow on the other side here. And yes,
I'm sorry. I'm
it's
switching
fine.
everywhere.
It's fine. So we also learned yesterday that the flap can sit inside the tube. With that information, and then Jimmy, the developer, started to argue for a design that Jimmy didn't want to argue for because it's for the movement of the plates. And
He fell into that trap, did he?
He fell into the trap. And it's so I'm trying to learn to define my problem definition. Back in the days when I made a Pixar video and tried to learn to design with this theoretical process, I actually made some monsters, and problem definition was one of the monsters. There's more monsters. If the design requirement is the final boss, the problem definition is a minion of the design requirements. And so fun yesterday, people said like, design requirement monster boss is finally taking some damage. And I love that. One of the problems, or one of the solutions then, is to have the resonator move with the bar. And the resonator for this small note is only 5 centimeters long. So this is a 1 meter tube. It's not like we're going to have a 1 meter tube moving like this. The resonators are pretty short. So today, for this stream, with the knowledge of yesterday, I'm now going to start to design a prototype that will test the tubes moving with the bars while the flaps are being still. So we need to cut a slot. I can show here in the wide. We need to cut a slot here because we don't want this spinning axle to move, but this plastic tube is going to move. And we need to figure out like a new pivot point. So actually, let's go over and set up some stream objectives for today. All right.
Oh, wow.
So we can go to the sketch, I think.
Oh, yes, we can. Boom.
So, new sheet of paper, new stream, and Wilson is with me here. So, today I want to check pivot point, which will like determine. So if I draw the tube here, I want to know what kind of slot we have to cut. Perhaps it's a curved slot like that. Check pivot point location. And also what is so great with this is that the tube can now be part of the structure that holds the bar. So the tube and the holder has now become one in this solution. So if this is the holder and here's the vibraphone plates, boom, 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 this piece here can now be one structure, which is mechanically super, super nice. So we're going to also like design tube holder 2-in-1. Tube holder 2-in-1. 2-in-1. And those little things here are our silicone prints. And on the real deal, the tube might be aluminum, thin aluminum, like on my real vibraphone. But today we're going to work with the PVC, and we're going to do this in a 3D printed prototype. So these are basically, if we're lucky, I can start to print as well. Start proto print. If I'm being effective. Efficient, thank you. It's hard to talk in the beginning of the streams.
It's early morning, you know.
Yeah. No, and so I'm feeling great, and I'm talking to Jasper in the evenings, and we're getting some design requirements experts in, because I feel when writing design requirements, I so need someone to talk to, and there's a lot of people who wants to help. So when I don't have an expert here to help me, I'm going to go back a little bit into my comfort zone, but we're doing this to make the digital twin. So I checked my old design process, and on the first machines, so this is not tinkering, this is to inform the digital twin. On my first machines, I started to build in the real world. What I'm trying to build is a CAD design, a digital twin of the real model, and this digital twin will be fast to iterate in. That's the idea. So yeah. I also think that we can do this.
Oh no.
Oh, did we press at the same time?
We switched at the same time.
Okay, let's go. Let's do some nice CADing here. All right. So, how are people in chat? Are they happy?
I have a couple of questions here early on. We have from Jimmy, first off here. As we're going back to prototyping for movement, I'd love for the visibility question to be addressed more theoretically. Assess the visibility at a distance question first.
That's a good question, Jimmy. We have addressed it. It's
and Jasper also. Requirement, the plate must move up and down 10 millimeters or something. We discovered this number from testing by watching far away.
Thank you both for being here. You're helping me so much. I love these superstars that keep on coming back to chat. So thank you, Jimmy, and thank you, Wintergatan, Jasper. So can you bring up Jimmy's comment again? Oh, I hear a disturbance in the force.
In the force. Yeah.
We've synced. And that sounds good now. So, to answer Jimmy's question, is that when I go to a classical concert and I sit at the very back of a grand theater hall, I can see the pianist pressing down the keys. And that makes the performance so much more interesting. The visibility on a distance, this is a pattern. So if there was just one key in the air, you wouldn't see it. But so it's going to make a big difference. And especially most eyes on this machine is going to be Wilson.
On Wilson.
Trying to take back to me. I don't want Wilson. Wilson, you. Most eyes are going to be in the cameras. And in the cameras, it's going to be great, but also 100 meters on a concert will see the movement. So we have actually...
Here we go again. 100 meters, I'm not sure.
We have addressed that.
And chat, as always then, do you really see the keys or do you see the fingers or the hands moving.
Yeah, so I'll say you definitely see the piano keys. Go and look at a concert video on YouTube and take when they take this big big thing. You'll see it.
And Jasper added here, Martin, did you look at the thing I added to the sheet? I tried to build part of the trunk.
Nice. Let's go and see. Jasper actually worked on this yesterday night when I was sleeping. I think Jasper has done. Oh, look at this. Jasper coming in clutch. So. Main problem. We must go on a world tour with a marble machine. How can we go on a world tour? We must have... Wow. Jasper did some work yesterday.
Oh my goodness.
Wow. So nice and beautifully visualized, Jasper. Thank you so much. 81 rows of work here, Jasper. So this is the theoretical underpinning of the prototyping we did yesterday. Oh, and we can actually change, I think, Hannes, if I'm sitting here. Can you change my mic?
Oh, yeah, I can.
To the SM7.
Yeah, there we go.
Okay, we're at the SM7 instead.
Yes.
Fantastic. Okay, so this is fantastic. And I won't go into this in this stream. I just want to say how fortunate I am to have a God-level design requirement expert. Jasper asked us to call him that.
Yeah, the only God.
Yeah.
The one and only.
I was like, oh, you're so kind helping me. He's like, I have one only wish in
one
return.
requirement.
I have one requirement. As long as you introduce me as a God-level design requirement expert.
He's humbled that way.
So I'm not going to go through this in this stream, Jasper, but this is obviously fantastic, helping me through this. I'm so happy. We're going to go into it hard later, but what I feel, if you can bring back Jasper's requirement comment there, I think we should add that. So on functional requirement, instruments, vibraphone. Each vibraphone note must communicate when it's hit to the audience. But then moving down is the 10 millimeter is a solution. But let's add it here. The plate, the vibraphone bars must move 15 millimeters. Downward when hit, measured from the marble hit point perpendicularly from the with the plate. I mean, I don't know if I spelled that correctly. So that might be a bad design requirement in some ways, but I'm gonna leave it like that for now.
Okay, good. I think Jimmy has done a lot of thinking about this visibility thing.
Yeah.
So Jimmy says here, like, please watch the video from like 4 meters away and see if you see it. If you're 4 meters from your screen, it looks as if it's 25 meters away. I'm guessing the original Marble Machine video.
Yeah, so
then you can simulate how much you will see from 25 meters away.
Okay, so I think, like, if we take this as a learning opportunity, I think Jimmy is correct in the methodology, but I think I shouldn't make assumptions, but I also think, like, if I'm constantly having to I do know some stuff, but of course I thought I knew that the Marble Machine X would work because I was using CAD. So to question our own assumptions is of course really good, but I know with 100% security that when we release the first video of the new Marble Machine, when I set the camera angle on the Vibraphone, I know that it will keep a child watching the entire video mesmerized. If the plate moves, that child is going to be less mesmerized if they don't move. I just know, I know that. I know that for absolute sure. And so, like, I think you're completely right, Jimmy, but I think for the sake of, like, yeah.
I think like you're looking for the sweet spot between two, right? It will never be totally visible 100 meters away, but it will be visible semi-close to the stage, and it will be very visible on video.
So what will be is that from 100 meters away, the marbles are going to feel like a blur. It's going to be like, you're going to see some movement there, and you're going to see some...
Uh-oh.
some blur in the air. I'm going to go get that marble. I want my set complete. It's like, it's going to make a huge difference. I absolutely know that. But should we bring up?
I think perhaps people, and it's easy to get stuck that everyone should see everything all at once, and that will never happen. The movement is gonna be cool because, I mean, if you're close enough, you will see it. I don't think you will ever be able to see it too far away, but that is not the point.
You'll see it from 100 meters, I'm sure. 100 meters, maybe.
I 25, yes.
So here,
100, no.
Here's one of the most important camera angles, like this, and it's going to be like when the machine plays. It's going to be like, I'm trying to select the faces there. Boom, 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 ding. And since they deviate from this pattern, you see the movement. I think it's like beyond. To me, it's. But so what Jimmy's asking for is that I should be more theoretical in assessing this. Let's get I'm gonna go look at a piano video on YouTube from 4 meters. Let's do this concert piano.
Google piano concert from 100 meters away.
Okay. I don't see them moving.
No, you need to find a good one.
But I do see... Okay, here we have a good one. Okay. This is actually a good one, but
are we gonna switch over?
No. I want a full... I don't want shorts. How can I get YouTube to stop with all these shorts? Is there a camera far away? There is a camera far away. The angle of the piano is... So there you can see the down press. You see some wood there. You see that there's wood coming up on the... This is not from 100 meters.
No.
But you can see the wood. They have another camera I saw previously. They will switch to the audience camera soon. But the angle of the piano is not... Where can we go to the... Can we go to the far away one? Here. Okay, there's a new piano player. Are they competing with the same song? I think like I have to be. I think I have to learn to trust myself a little bit more.
I don't trust that guy, I tell you that much.
You mean Jimmy?
Wilson.
Okay. So yeah, it's good in theory, but I think the truth is that I know for a fact that it will make a huge difference. I know how complicated it is. So I'm going to actually go and write in just that because we have a requirement. There is a requirement.
That's the point we're making.
The vibraphone must communicate. Look, the vibraphone must communicate when it hits to the audience. It's going to do that by the marble gate showing with a finger that it's dropping. It's also gonna do that by the plate moving and the funnel moving. It's a whole mechanical music theater happening for each note. So what was the point we're trying to make is to just underpin it more seriously and question my own assumptions.
I don't know. I just thought that's the point we're making. Someone's saying here.
Okay. By the way, talking about, I talked to Jasper the other evening that, you know, on the first machine I could play manually, and so now there's this idea that perhaps that was really hard to play music. Perhaps I can have a mechanical keyboard from the control station, so I can actually drop the marbles with piano keyboards. So I could actually like play. Imagine in a concert,
magic.
I played that with marbles, you know?
And my Memeplex says, Hannes, different views equals different movement. That's the point they were trying to.
Yeah. So I think what I feel when we have this discussion is that I feel this perfectionistic frustration that I can't satisfy all points at once. And I think what I need to be much better at in this whole process, because I think the streams gets frustrating for like everyone, is to be like, that's a good point. But that's not what I'm going to dive into right now. To keep on track with the idea for the stream a little bit. So great point, but I think the movement will add immense value to this art piece. That's why I loved the movement, is why I fell in love with the animusic thing. Yeah. I've been trying to make the movement on all of the all of the machines.
And that's the problem with this, because you're talking about something that is magical and really hard to define, and people want hard numbers to it.
Yeah, so we have to find the sweet spot between those. All right, but there
we go.
I super appreciate appreciate that, but it feels horrible that I can't always like have the perfect answer, but I have to learn to live with that.
We have a really nice donation from DJ Ice Pole with a question. With all the hype around, I guess, Angie de Potrin.
Yeah, I watched a lot of those videos.
Don't you think it's time to scrap the latest marble machine and make it twice as difficult to build because it's not microtonal yet?
Thank you, DJ Seapole. When I saw them, I was like, oh, they're actually great. They call them the new French Daft Punk. Have you not seen those videos on?
Yeah. Okay. They have been everywhere.
Yeah. No, microtonal I've never been interested in, but I love watching their videos. All right, first point, check pivot point location. Let's go for that. I think I want to start on a new part studio, and I think I'm gonna derive this part. The bar, or should I duplicate? Oh wait, I think I can duplicate this one instead. We're gonna rename this A3 uni holder. So it's a unified holder between the tube and the holder.
Unicorn holder, got it.
Uni holder. It's a and I wonder if I should keep this in. No, I don't want to keep that in, actually. I want to start fresh here now. So we're going to roll back the history bar a lot. We have a lot of crappy CAD design in here.
Look away, people.
You see how many features I'm rolling back here.
Mm-hmm.
So where actually? Whoa. Yeah, high time. There, I think we are. Oh, wonderful! This is going to be glorious. I'm going to delete all these features. Delete. Boom. Turn dark reader off. It is off. Okay, it gets stuck sometimes. It's fine. So now I want to be. We sketched this first bar using the configurations up here. So we did that really. We did that really well here. So I wanna be really disciplined in how I build this up. Does Jimmy accept the truce?
I don't know. The discussion is ongoing in chat, but I feel like we should leave it for now.
Okay.
And our old friend Hal is here as well.
Nice.
As it turns out, the entire exercise with the design requirements is a waste of time because Martin knows what he wants to do, and he's just going to do it. Like I've been saying the entire time.
There's absolutely some truth in it. I think the return on investment in my theoretical thing isn't there yet. Hopefully, when we have the World Tour premiere, we don't have to cancel the concert because of the design requirements in that, and then the return of investment will be there. But right now, we're in a high depth of all the time that I spent trying to get that on board. And I think Hal made a point, if I don't, maybe I'm hallucinating, but writing down a requirement isn't the work. Following a requirement is the work. So I'm completely aligned there.
And now I got a question here from Astro. Is Hannes team static or team jiggly? Do I want to add fuel to the fire? I'm 100% on team jiggly. If it seems that it's possible, but if I sense that it will be derailing way too much and adding years to the process, I can live with being team static. Absolutely. But at heart, I am a big dreamer, and I've seen Martin pull rabbits out of the hat many times before, so I'm not willing to give up yet. And when he has an idea, you should not stop this guy. Hopefully it will work out.
Team Jiggly has a branding issue. That name is not good.
Why?
Everyone in Team Jiggly sounds unserious.
What? It's like Jigglypuff.
Team Awe and Wonder. Team Life is beautiful.
Team Magic.
Team Magic. Team Life has a meaning. Team Love exists. Team.
Okay, we got it.
The world is
Stay
beautiful.
focused. Yeah.
Okay, so now I'm having trouble with. I think Dark Reader is stopping my. So I have to just go. Yeah, I have to become better at staying focused, actually.
Yes, we're gonna stay focused and positive.
Yeah, thank you, Hannes. Now the dark reader is gone. Let's see if my sketch works. Yes, me.
And DJ Icepole with another donation and a comment here. Making the rules is easier than following them.
Yep.
There we go.
Okay. My menu didn't show up because I pressed the wrong place, but now the colors are correct. So we're gonna start this by sketching on a mate connector. And I learned something really great in Onshape. It's that I can set the primary axis using the default geometry. So I can use the front plane. That was the wrong one. I can use the right plane to turn my sketch completely correct. And if you remember this discussion, now this sketch thing is correct. So we're not sketching back and forth and upside down. So we're sketching perfect here on this mate connector. And this mate connector sits on the very first sketch of the bar. So we are in good shape here. And I'm going to name the sketch. I'm going to name it sketch pivot point. Because as we saw, that's the first thing that we should do for this stream. Like, I think also I'm prepared to buy off the shelf metal gears and not do all of the gears of this machine theatrical. I would love to do all of these gears theatrically large. So I think like this is kind of the first thing we do. And I think people want to see me simplify the machine, and they get worried that I'm still not learned that lesson. And I think there's other darlings that I will be prepared to kill. Just this one, I will only kill it when I see that I can't make it work. And I'm like I'm a simple prototype away from having the answer. I just want to get there, basically. So yeah, we're gonna find the hit point of the plate. It's in here somewhere. I think it's here. What sketch is that? That's a hit point sketch. Is it? No, it's not. This is the hit point driven by the variable. So let's name that sketch. Sketch hit point. Because in my new sketch, there's a disturbance in the foreskin here. I want to use this hit point. So now we're going to decide an angle of the plates. Let's use that. How the marble comes down here. That looks pretty. I think 20 degrees is better. So 90 minus 20 is 70. So yeah, I keep coming back to I want everyone to be happy, Hannes. I want to please everyone, and I just have to like learn that.
Perhaps starts with yourself.
That
what makes you happy, Martin?
That's a good thing. I also think like doing art is to accept. You put yourself in the arena. You have to accept. That everyone is not happy.
Yeah, as long as you sleep well the night before. That is a requirement, right?
How do you mean?
You need to sleep well the night before the concert.
Aha! I was thinking about yesterday.
You need to sleep well, Martin.
We're gonna make a circular pattern here to simulate the movement of the plate here.
Got a question for you here, Martin. You can read it yourself.
Styret. That's my friend Styret. Hur mycket bättre är on-shape? How much better is on-shape than Fusion 360? 0 to 10, Styret. Nice of you to be here. Well, I can't really say. I'm having much more fun. It's better for shareability. It looks better. I love it. This is how you change. This is not like in Fusion 360, how you change the midpoint of a circular pattern. I'm gonna put it on that one. 8, Styret. 8.
8. Good one.
I just want one repetition, and then I can change the angle like this, I guess. But I want to go past that point. Can't I do that? 180 degrees. Do I need to go here? Minus 10 degrees. Can I go negative? I can't. Then we need to go 350 degrees. So here you can see how the movement starts to... So let's do a 5 degree. 355. And what I hope this will do here for us is that we can move this around, and we can see then how here you can see if the pivot point changes, we can see the movement. So I want to include in this pattern the hit point. I'm a little bit bad. Can I click here to include more that I didn't include? So to edit a previous circular pattern in Sketch, I don't know really how I do that. I want to add this point to the pattern as well. Can I right click it? Edit pattern. Oh yes, nice. I want to include this. Oh yeah, then the little hit point appeared there as well. Let's include the, no, let's not include the marble thing.
Styret is back here. 8 is fair enough. Keep up the good work and please take over the world.
Yeah, Styret might come on the tour actually. Styret is a fantastic event planner and drummer and drum technician. He's been polishing the cymbals for Europe, everyone. Yeah. So not only polishing the cymbals, he's been like...
The band Europe.
Yeah.
Final Countdown Europe.
Final Countdown Europe. So...
And his biggest feat was he shared space with you, where we made the first Marble Machine video.
His biggest feat is that he was neighbor with the great Martin Molin once. So he will have his place in the history books. He's a great guy. Great guy.
Fantastic guy.
Also played with Detektivbyrån in some concerts as a drummer.
Oh.
So now I wanna see the slot needed for the different pivots here. But first of all, let's do so in the design requirement, we have a 15 millimeter movement perpendicular to the top of the plate. So let's put a 15 here. I'm following the rules that I just made up. So, okay, I'm gonna change that with the degrees, of course. And then I think the shorter the arm, a little bit easier everything. The longer the arm, a little bit better movement, more place for dampeners and stuff. So let's leave that unconstrained for now. We're gonna have less angle, 356. So we're getting closer to this 15, 357 is just a 3-degree movement. Beautiful. Let's see how long. Why did this line? These are lines from the pattern, all right. So perhaps I should constrain. Should I constrain it like this? So the more perpendicular I want, let's add a line like this. I want it to be perpendicular with this. And then let's edit pattern and include this line as well. Now we can kind of see how it moves. Eventually I want to include the tube and everything here. So we can see that the more so when I move the pivot point down, we will have a much more forward movement of the plate, which will be harder to cut a good slot. So we want this blue line and this white line, if they can follow each other as much as possible, the slot will be smaller and easier to make. So that's why like a high pivot point like this that's also going to be beautiful, because you know what then, Hannes? Then we get the pattern also in the arms. We'll see the arms, but we have less place for drums here to the right. So there's a lot of aspects. And we want to reach under here for dampeners and stuff. So perhaps I should draw out the arm. So I think what we should do is actually boom. Gonna have a center point arc. If I make it from this point down to this, it made it the other way around. This is the path the point is following in the movement. That should be blue too, good. So yeah, it's if we can have the pivot point like here, it's going to be really simple. But we can also cut the slot a little forward. But then the flap, now I think we really need to go as much as this as possible. Now you can see that the arc is not deviating almost anything from the straight path. So let's see how it would look to have a pivot point somewhere here. Let's add the tube to the pattern. I should have used the entire Vibraphone profile. Let's do that if we're going to use also these curves. So we see the bottom of it. This is going to happen, Hannes. I'm not talking about the movement, I'm talking about the machine.
Yes. Have I ever doubted?
You are a dreamer like me.
Yes. Someone here is also believing. With a generous donation, it's our new friend here, DJ Ice Pole, that says Wedgwood rooms in Portsmouth on the UK part of the tour, please. Check out its history. Obviously, it's more convenient for me. And we want to make it convenient for you, Ice Pole.
Definitely need to go there.
We need to cater to you.
Thank you, Ice Paul.
Absolutely. We should go there.
100%. So now, I'm going to draw the axle of the vibrating flaps. It should be on this white. Is this line really perpendicular? This is what I felt. This white line is wrong. Yeah, I constrained it wrong. I think it would look so straight. Looks so wrong. So I think I need to go into this perpendicular command constraint, remove it, and say Shift L. You are perpendicular to you. Okay, there we go. I thought it looked off. So there's many ways of finishing this, and keeping focus is probably like my focus has gone up, but I'm still thinking a lot about the content creation and the camera angles and stuff and the sound and everything. So I'm going to leave much more to Hannes and Alphonse. I'm in great hands. It's just me it's easier for me to think about a camera switching technique than to think about the marble machine kind of. So I have to stay.
Why do you think that is really? Are you at a really difficult point? Is it this whole?
Because I doubt I can do it. Because it was failing with the Marble Machine X is one of my biggest shocks I had in my life. Like letting 10,000 patrons down. It's like it's a huge wound for Snowflake me. So thinking about making a Wilson cam is much more fun. No, it's not really that. Okay, back to focus, Martin. Let's now add the resonator tube. Should I have done this in another sketch? Should the movement be in a separate sketch? Because I'm always like, there's so much lines here. Then I can just click the sketch on yes. Because this is going to be complicated, I can build this up in 2 sketches instead. That's what we're going to do. I'm going to remove the 3 degrees movement from this sketch to have more control over this simulation, 2D movement simulation. Because it became a bit hard to draw. So in here, we are just going to, what's this point? In here, we're going to draw the first position. And then we're going to use a lot of that geometry. So let's draw the tube. I think I'm going to draw it as rectangles, actually. Even if Derek would have something to say about that. Currently, it's 1.9 wall thickness. Oh, 1.9. And the outer wall is 1.9. And the outer wall is 20 millimeters from the center.
Could you just please remind me and everyone else what we're doing exactly right now?
Yeah.
What are we CADing?
We are finding the
Pivot point.
Pivot
Why?
point location. To see the slot for the moving tube holder in one. And also to make a digital twin of the entire marble machine. So I want to print this to get the prototype going, to try dropping marbles on this. So here's the tube. Oh, you know what's fun?
What?
This distance, we figured it out in the design requirement. It's 11 millimeters.
It was fun.
I'm I'm in control. And then we also figured out that the flaps shouldn't be, if I write the flap from the side here, it shouldn't be a perfect round. It should look a little bit like this, like it does on my real vibraphone. So this yellow is actually going to be the flap. So if I now do this is the axle of the vibrato. And on the flaps, so the flap from the side, we're going to revolve that. So let's actually do, how can should I sketch that from the other side? Let me just figure out this distance here.
Before you do that, read this nice super chat
24.
from Hasse, would you?
Hasse, listen to vi säger inte usch till en skiss i tusch. Vi säger inte usch till en härlig dusch.
That's Martin's newest song.
Thank you for being here, Hasse, and spreading the good vibes. So if this is the flap, let's say 12 millimeter looks kind of good. Yeah. So we're going to do, this is the shape of the flap for now. Perhaps 11 looks, no, wait, I meant 13. I think 13 could be a starting point. That means that this length is 13. So I'm getting some info here. I don't need a flap yet, but there's going to be a flap going up to the surface of the tube like this. Wait. No. Yes. Okay, sorry. This is not going to move, meaning we need safety distance. This is actually not true. It's the safety distance to the top of the flap that I should add. So let's just do the flap. I should be better at using mirror. I should mirror this as well. Junk. So we're gonna mirror this over that, and we're gonna mirror over this line. We're gonna over this line we're gonna mirror these. So now the safety distance to the top of the flap is actually what's setting the position of this rotating shaft. And if I'm gonna go for ambitious with 15 millimeter movement, how much we need more than 15 from this point. So let's add 15 plus safety distance to this point. Should we start with 20?
Let's.
Just for, and then this distance is 13. Okay, I was wrong there, 13. All right, we're getting somewhere here. This should be really thin. 0.5. Nice. Because these walls are moving with the plate, but these flaps are not moving. So now when it comes down around 15 millimeters, we're gonna have a safety distance to the flaps. For fun, let's compare this to my physical prototype I made yesterday. We have 22 millimeters here. So let's go to the tube.
Oh, and let's switch over the sound.
Smart. So we're on the wireless now then.
Yep.
I'm just checking this distance. We can also do that in the wide. Okay, so yesterday we were only like 16 millimeters down on the deep one. Which means the wide is acting up, huh?
Yeah.
Okay, we were 16 yesterday.
16 yesterday.
Yeah. So let's do this a bit closer, a bit tighter. So now we only have 3 millimeters. So we're 20. I think this is good. Let's pull these down. I think that's kind of all we need in the first position. So now let's do a new sketch. I wonder if I can choose the sketch plane on another sketch. No, I couldn't. We're gonna put it on the right plane like that. We're gonna do another mate connector on the same point here. But I wanna hide all the new sketches. Sometimes the hide symbol is not there. Is it because we have locked stuff? I don't understand why here I can. I don't know why I can't hide them. Okay, never mind. No, okay, I did it wrong. We're gonna use a mate connector. And then we're gonna locate the mate connector using the plane. That's how we're doing it. Primary axis should be that one. Good. I want to see all this. And I want to use kind of everything. Can I just use like this? I can. Good. I'm trying to get to the second position. I'm going to use that one as well. Use. There it took. And in this second sketch that we're going to rename to second position, we're going to do that circular pattern with 3 degrees movement.
Is the intent to fully CAD the prototype? Jimmy wonders. We'll need a full counterweight and holder for the prototype.
Yeah.
Yep.
I think yes. So let's do a circular pattern of Can I start with the? I'm not super friends with the circular pattern. I wonder if I should choose the pivot point first, then choose a circular pattern. Yes. No. I'm choosing what I want to pattern first. Okay, so let's cancel this. But it still created a pattern. Can I redo that? Circular pattern. If I now choose this and I pull the pivot point over there. Okay, now it works. 2x. What did we say? 357 degrees. Where's the degrees? Three, 5, 7. And funny, I chose the flap because we're not going to pattern that. We're going to pattern everything else. Why aren't the lines here? Okay, we have to redo. Okay, it's going a bit slow here, but I didn't get the lines from the tube. Do I have everything I need now? Let's hide the bar. I got more than I wanted there. It's fine. Circular pattern. Let's just choose something. Pull the pattern point there. 357 degrees. 2x. Here we go. And I want everything. Now we can start to see how the tube is moving. The flaps are not moving. I want the outside of the vibraphone bar. Unfortunately, when I chose to use everything, I got all the geometry of the bar. This is why I shouldn't have added chamfers and stuff. Because of all these extra things. It makes it messy here now. Can I deselect the line from the pattern? Apparently not. Great. That's the second position. So now we can simulate the movement here by just adding or retracting that second sketch. I want to turn these into construction lines. So we don't have this. I want to clean this up actually because I have a lot of lines here that I don't want. See if I can just remove them. I can.
And I see another donation here from DJ Ice Pole. We're lost in CAD sketch. Feel so alive. I quit my 9 to 5. We're lost in CAD sketch. That was a deep cut reference. I didn't take it right away.
Okay, I'm lost actually. I'm lost in the reference.
Lost in music, perhaps.
Is it
It's a song.
It's a song.
Yeah. A banger song from the 70s. By Sister Sledge.
Ooh. Thank you, DJI Spol. DJI Pol. I read it as the drone brand first.
DJI.
I tried to be fast when using everything, and now I'm paying for it.
Oh no.
There's like all of these lines are 2 lines. So I want to clean this up to be clean.
Do you know what does need to be cleaned up, Martin?
Tell me.
Our love to our wonderful backers.
Yay.
The last 24 hours, we got 19 new Wintergatan backers.
Is it
through
true?
YouTube memberships, Patreon, and through Twitch subscriptions. 19 new ones.
That's fantastic.
Yesterday was a great day. And I recognize a lot of those names on screen there. That was so fantastic. What a day. We appreciate you all very, very much.
Thank you all so much for supporting this. You're the light that Galadriel gave Frodo.
The light of Elendil.
Yes. Okay, I can choose like this. I've been choosing stupidly. No, then I get... Okay. We're soon done with the cleaning. I made a mess here.
Jesper Hagström is saying, having Martin talking to himself while catting is perfect background noise while I'm catting at work.
Oh, nice. Jesper, what are you catting at work? I'm curious.
Movable vibraphone plates, perhaps?
It's fun to hear people who are actually professional in CADing, see what they're doing. Often they can't like tell because it's secrets.
Yeah, it's military.
It's always some military secrets. We're soon done with this. Phew. I don't want this one. Let's get rid of that. What are these points from? Let's keep them for now. So I think I should start constraining the pivot point. So when I go back now to the first sketch, I can change the position of the pivot point, and that second sketch is going to follow. So let's, for fun, just pull it out perpendicularly from here. So Shift L, this line is perpendicular to this, or collinear with this. Is this the middle line? Yeah, I think it is. And we're going to say with I that you are coincident with you. And I can manipulate this position, and the second sketch should follow. It does. Good. So let's set a distance from center, perhaps. An arm distance. Maybe 30 centimeters? 300?
Short arm.
Yeah, we had, like on the Marble Machine X, the arms were really, really short. And it makes it easier to build. Perhaps it should be shorter. I had this idea that because I think the length of the arm, it's the height of the arm that is the important thing. So I'm missing some. Let's turn these into construction lines on the second position. So again, we can now see the movement with the second sketch here. And what we want to figure out is the slot of the flaps. Here we see the safety distance when the bar is maximum depressed. The bar is happy because it's moving, but it's depressed as in. Thank you.
I don't know why I love that so much.
It's because of the hard times we're in, perhaps. So I've done stuff like this before. I don't remember where I should. Wait, perhaps a circular pattern the other way for this ring will give us. Yeah, if we do a circular pattern of this ring the other way, that will show us on the first position how this will move. So that will give us the slot, actually. in this position. So, but I think I should do that on this second sketch. I have to keep my tongue correctly in my mouth here, because that's moving up. We want to know the position on the first sketch. So let's do it on the first sketch. I should then use variables actually. So we're gonna make a circular pattern of this shaft, but the middle point, and now I see the middle point always starts at the center of the sketch. It kind of makes sense. I didn't know I chose that point, so we're learning here.
Do you want to hear something nice, Martin?
Yes.
From Carl Westklev. Martin, the Ronnie the Rocket of creativity, Paul Macbeth of skills, and Cal Newport of productivity.
That's way too kind of you. Thank you. That's I'm gonna aspire to make that make sense. Thank you so much, Carl, for the positivity.
My memeplex is wondering here, you need to add the flap in a horizontal position so you know if the flap touches the inside of the pipe.
That's true.
Or affirm that the flaps have big pieces cut of them, like the MMX.
Yeah. So this is I did this here, the exercise. So the good thing with this design is that these are cut away. The little, only the yellow is the flap, and then in the first sketch, we can see that the flap here is going 13 millimeter out from the center. So if we also we can actually make a circular pattern of the flaps, or we can actually make a construction line on the furthest point, which is that. So here we can see the flap is far away from the edge of the tube here. It's 5 millimeters, 5 millimeter space from the edge of the tube.
Great.
In that direction.
But the whole pipe moves in 3D, so the other side also move.
Very good point. Very good point. So we have to look actually perfect, my memeplex. I had that thought previously, but I actually forgot about it now. So super happy that you're saying that. So now we see in this pivot point, this pipe is coming closer to the flap. But this is actually not all true, because we can have interference in other parts of the flap. So we should actually we should build these parts physically. We should extrude these parts because there might be interference on other parts around the perimeter of the flap. So here we can see that the wall is getting closer. So can we find a pivot point where the wall is staying more perpendicular? I think we can. I think this point should be perpendicular to the center. Okay, now we're getting somewhere.
Then my memeplex says top-down view.
Yeah, top-down view is
top-down view.
Good, my memeplex. Thank you so much. That's very useful. I think I made this perpendicular to the plate, but we want as little movement as much around this point, so we should make it perpendicular to this point. So instead of this line to the pivot, I think if we pull this down, we can already see here how this goes more straight up. I think I should make this line that the pattern created, Shift L, perpendicular to the center line of the tube. And if we now go, here you can see how chat is actually saving me from making mistakes. If we now go to the center position, you can see that we have much less movement of the walls of the tube in relationship to the flap. Thank you, my memeplex. That was such great input at perfect time.
That was perfect. And another thing that's perfect is Carl with another comment here that says, Hannes, the Keanu Reeves of amazingness. And I'm not as humble as Martin. I will take this and run with it. Thank you so much.
Carl is on Hannes' level of hype. I'm loving it. I'm loving it. We have to check something more on this second position. We have to check how far the marble is hitting off the perfect hit point. So in the circular pattern, edit pattern, I want to include this little point. It appeared there. And then in the second position, we can extract a line. We can use this line, which is the incoming marbles. And I can make a line that is coincident with that line by hitting, is it Shift L? No, Shift L is, no, it's just I. I for coincident, of course. I had a line in my mind. So here we can see at this pivot position, the marble is hitting 5 millimeters off the perfect point at the most depressed point, which is fine. And the tube is really moving super nicely around around the flap. So now we can make that arc. And we're gonna turn that into a slot. We're getting somewhere. A center point arc from, okay, I have to make sure that why is it showing from there to here? No, from there to there. So this little line, I think we can make a slot with the offset command. Where is the offset? Am I too zoomed in to see it? Alt C for search. Oh, I'm in the, what happens here? Curve surface analysis. No. Search tools slot. That's the offset. Oh, sorry. Offset has a slot hidden underneath it. We can make a slot from this line. So now we just want to decide how much space we want around the shaft. So say the shaft is 10 millimeters. Do we want 3 millimeters of space, perhaps? We got our slot. That should be the correct slot for this pivot point location.
Jimmy says here, prototype will need holder for flap axle as well.
Yep, good.
And we have a follow-up here from Jesper with the CADing. And he said, I'm working on machining fixtures for a CNC machine, but unfortunately, I can't talk about the parts I'm making, as per usual.
That's with the pros. Good luck with that. Super fun to hear that there's real professionals in here. I'm going to try to make you all proud in the end. So, did I add that slot to the first sketch? No, I didn't. I CAD'd that slot in the second. Okay, that was stupid. I should have made that slot in the first one, but let's remake it. First, we need a center point arc from here, from this little point to this point, and then that's little arc is going to turn into a 13 millimeter slot.
I don't know if this is too early to answer, but Handry F wants to know, did we figure out the equation about energy needed to displace the bars plus acoustic energy versus energy from a marble drop? The inertia of the displaced unit looks significant.
Yep.
In other words, does a marble drop have enough energy to move all of that plus hitting the bar hard enough to make sound?
This Handry is, I think, like the absolute best. Is a really, really important aspect and one of the better argument against the movement, because energy input on the machine is a scarce resource, very scarce resource. So we have to use the kinetic energy that we're building up by lifting the marbles well. And this is a machine that mainly produces sound, and we're wasting that energy. We're taking it away from the sound and we're putting it into the movement. And it's one of the things that I really dislike the most with the movement solution. The good thing is that these resonators are very lightweight. And also the good thing is that thanks to the resonator moving, building the holder that we're going to make now, like some structure like this, instead of having to work around a stationary resonator, we can now incorporate the resonator in the holding structure, which means some of the weight that we're pushing of the tube, we would need to add some of that weight in another holder and space. So it's not the full mass of the resonator that we have to move extra. It's actually the full mass of the resonator minus the material we're saving in the holder by having the resonators move. But still, you're asking the absolute right question, and it's one of the things that annoys me the most with the movement. I think I have everything I need here now to start making a prototype 3D printed support structure for this note. I think I should add the position of these holes to the first sketch. So we're going to build, and as you can see, they're not at the same place. I'm gonna add both sides here. And we're gonna build a holder in the first sketch, and this second position is just to, the second sketch is just to check what's happening with the movement. I can actually see here that the plate moves more than 15 millimeter. I think that's too much. So what do we do to change that? I think we're gonna reduce the degrees of our circular patterns. And I think we should add that to our variable in the configurations, because I have that value in both sketches and I shouldn't do that manually. I want to control that from a central point. So we're going to here add a configuration variable. Oh, it's up here. Variable input. Degrees of movement is an angle input, and the default is going to be 2 degrees, and the minimum is going to be 1, and 360 minimum, maximum. So now we have that configuration. It appears up here in our super nice menu. I love this with Onshape. It makes me feel like a scientist. So now we're going to go into our sketches and we're going to replace those constraints. So here we just have this 357 degrees. Oh, one is negative and one is positive. That's annoying. I don't think I can do negative. So let's try just writing degrees of movement here. this is going to break everything because it's going down to 2 degrees.
Jobo with a donation and a nice comment here. These pivot points gives me good vibrations. Ha det gott, Glenn.
Thank you, Glenn. A lot of nice,
Nice Swedes here
positive
today.
Swedes in here. So let me see if I can do negative. I'm gonna do a minus degrees of movement. I could. It moved the correct place. Fantastic.
Thank you so much.
Yeah, thank you so much
wonderful donation and comment.
for the support. I'm gonna make you
Highly
proud.
appreciated.
Sorry, I talk over you, Hannes.
Yeah, it's just good when you do negative movement, we get some positive comments at least. That's good.
So here we have 3 degrees of the circular pattern. And here's, I'm going to do degree of movement. Boom. So now both sketches are getting their information from the same place. And now you can see that my 15 millimeter line is under the bar. So now we're moving a little bit too little. Now I can control that here. So 2.5 degrees. Oh, do you know how good I am at this? 2.6 degrees. Oof. There we go. 2.6 degrees. That feels nice. Okay, I'm happy with how I built this CAD up. And I'm feeling good actually. So now let's see if we can turn this into a physical thing. I'm first going to I want to make Derek proud by doing the should I make a new sketch, or is that no, that's kind of ridiculous. We're gonna start with a revolve. I just wanted to make a thin revolve, but I decided against it here now because I have everything I need to make the resonator tube here already. So we have our tube, and I'm just gonna check the length quick. We can do this.
I'll switch audio for us. There we go.
Can you try doing the zoom in on this one? See if we can find. It's gonna zoom into the wrong place. Back here, I'm checking the length of the resonator, and it's like 160, kind of. So back in this sketch, we're gonna add that value, 160. And we're actually gonna make it, it's going to be closed off. So let's add a bottom cap here. These are coincident. And I guess the bottom is a little bit thicker. So now when I revolve this, the resonator is closed, as you can see.
I just need to take a peek at this camera here. The wonderful chaos with the floor marble sign and everything right now. That is fantastic. I love it.
Eventually, I will also make a pattern of the parts as well, so we can see the parts move in 3D, like my memeplex said. I think we're gonna start by cutting out that slot. Pretty interesting if the slot actually would be below the surface, so there would be material here as well. That's maybe something to think about. I'm gonna show you what I mean. So there's going to be a slot cut out of this. So remove symmetric. I'm missing some stuff here. I'm missing this one. And I'm also missing the top one here. So we're really close to having this tube. It's a little bit of an assembly question, because if we have the axle, let's just pull out the axle as well in the normal position, which is here. It's going to be really long. If we close this off, we have to assemble the axle through all the resonators. But if it's open here, we can push the resonators onto the axle whenever we go. It becomes less sensitive in the assembly phase. Are you with me, Hannes?
I think so.
So what I mean is that if we allow it to be like this, the axle can go in and out completely here. So we're not restricted in how we're putting it together.
For now, open equals better.
Okay, expand my memeplex.
If open sounds good, keep it open.
Yeah, I think for the integrity of the holder, it would be really nice to have it closed. Because then it would give more support for the holder.
And Jimmy wants to know, Martin, is the aim to have only the marble do the moving or from programming wheel?
Only the marble.
Only the marble?
Yeah, that was a cool idea. I think it was Jimmy's idea to have the programming like pull the bars or something. That was a really fun idea that I never thought of. Are we back on the SM7?
Yes, let me double check, but yes.
Fantastic. Boom, boom, boom.
I'm learning.
You're absolutely wonderful. So I kind of want to make a little loop here. For the structure, but that would require assembly to be... I also wonder for the acoustics. This slot might change the... Let's do it fully open now. It's also easier for me to like cut with a Dremel or something for the prototype if I don't want to put the pipe on the CNC machine. So let's go to the first sketch and prolong this slot. So I want to have just an arc the other way around. Here's my arc. So we're going to make these arcs tangential to the real slot. There and there. And they're going to be also, I think, Shift O for concentric, which turns them into super long. So they have the same angle. And the only thing we need is that they go above the surface of the pipe so we can use them for cutting the cutoff.
AAPPBB asks, do you need the slot to be a bit deeper to allow an upswing after the first downswing?
Oh, interesting. Perhaps if it's closed on the top. Yeah, you mean there? That's... Thank you, AAPPBB. This audience is one step ahead. Absolutely love that.
Skating where the puck is going.
100%. That's such good, and that also talks to the positive stops. We're going to do a top stop here somewhere with like a nice silicone print on the arm and a bottom stop. We're also going to do a guide, a sideways guide thing, and the bottom stop should probably, I think the best would be over here. I think I don't want to allow the Vibraphone to go higher than this ever. So I think the answer should be, AAPBB, to your question, no. Because we're not going to allow it mechanically. We're going to have a maximum position. So we know that the Vibraphone bars are always sitting at that perfect position. And I think this should be adjustable with a set screw, so we can like really make sure the whole machine, the whole Vibraphone is like super flat.
There we go. Thanks. Great question.
Let's do this parallel to this with the letter B, and let's just make it white by constraining the distance. Very good question. And now we're gonna remove that fillet, and in this cut off operation here, we're also going to cut off the top like that. Slowly but surely. I wonder how this affects the acoustics. The good thing is that the distance between the plate is always the same. Perhaps this makes the resonant place being lower, so we need to get closer to the plate or something. There's quite a big slot in the real Vibraphone as well. All right.
You know what else has a big slot?
Tell me.
My heart.
Some backers fit into that big slot of yours?
Of course they do.
Timothy Chalamet, or is no. Best hair in the movie industry.
So 28 new backers the last 7 days. That is absolutely fantastic.
Fantastic.
We have a total of 1,224 backers, which is, it's crazy. It's ever growing. People are believing, Martin. They're starting to wake up now. They're starting to believe.
I'm so happy to hear that.
They're back on this train. This ride or die train we're on.
So happy to hear that.
Yeah, that means the world to us. You guys are the best.
Let me start on the holder. I'm going to sketch on top of the tube here just to get this correct. So finally we're seeing from another angle here. How am I going to do this? I want to hide some other sketches. This is annoying that the eye isn't popping up for me here. So I should be able to, there should be an eye here, like here. Some of the sketches, here's the eye, but for some reason on sketch 6, I don't get the eye. I don't know why. Anyway, I can hide it with right click perhaps. Hide all. Okay, let's just hide all sketches then. And show the sketch I'm working in. Okay, so now we're clean. So I want to start. This is actually not going to be symmetric. So let's start here. And here, soon you're going to see, Hannes, what I mean, that we can now make the holder part of the tube is part of the structural thing with the holder, which is one of the super nice things with this design. It's one piece.
One piece?
It's not.
It's the one piece?
I feel like Luffy when I can remove parts. I get positive like that.
Are you gonna be the king of the pirates?
I don't feel like I am. What do you think?
Sometimes we lose our heading. We need to find Nami quick.
Wait, Nami, is that the girl?
Navigator, yeah.
The navigator. So when I think in 3D, I often start like this, and I just do something, and it's going to be perhaps good, perhaps bad. So this is a new part, actually.
Yes, a heads up for you, Martin. We're at the 30-minute mark.
Okay, nice.
If you have something that you really want to do at the last push of this stream,
Nice.
or you're gonna be pushing on here with the CAD.
Yeah, I think so. This turned ugly. Who would have guessed? I'm just thinking here. I think I should. This should be much thinner. It also needs the slot. Okay, let's just keep on going with this.
Do you know that we have 1,160 followers on Twitch?
That's fun.
Yeah, we're growing steadily there. So far, people are finding us there.
That's great.
We're spreading around all different corners of the interwebs.
Fantastic. Can I choose you? This is the thing that I'm struggling with the most. Because Onshape isn't choosing sketch planes to extrude in the same way as Fusion 360 is doing. I'm trying to extrude this slot, and it's like I'm choosing other stuff here. What did I chose in a face? I do have a good list there that I should learn to use. No, I don't want to choose the sketch. I want to choose this circle. Where can I choose this circle? Okay, that went better. So I feel like a complete noob when I don't know how to get the extrusion correct. Merge scope. I always forget merge scope. Fusion did that automatically. We have a beginning, a humble beginning. I guess if we would print this, the top of the resonator would be part of the print. Oh, then we can print the slot. Of course. Good. Then I don't have to cut the PVC pipe, which means that we're just going to add a sleeve. I can probably print this whole thing, actually, thinking about it. But I want to be able to tune it. Then the PVC pipe is nicer. And then we can do wider. Yeah, I can print the whole thing, actually. Which is pretty nice. But it feels stupid to print the tube. Which then we are not restricted to... Ah, that's interesting. We can perhaps make it a little bit bigger then. Let's do this extrude as an add. So everything becomes one part here. Why are you not happy? There's some math here then. Okay. We're going to not do that. We're going...
No, math, boo.
I am... We should also leave air here. So this should be... This shouldn't look like this. I should just print the parts needed. Okay, good. I'm getting there. So let's go to this sketch.
Will there be a spring of sort in the prototype?
No, a counterweight.
Counterweight.
So we're at point 2 here. Design tube holder 2-in-1.
2-in-1.
That's what we're doing now. And I'm going to try to let the Vibraphone plate breathe by cutting out material here. So let's offset. Oh, let's just make that center point arc from here to that one. This is kind of symmetric, so perhaps I should use mirror a bit more.
Kind of symmetric.
Yeah, it's the reason is these holes are not symmetric later. So how thick wall do we think we need? Can we get away with 4 millimeters? We don't want this to flex too much.
Yeah, that's for the gym.
Of course. This one I think is going to be a bit bigger for the screws. Oh, then we can hide nuts on the back side. So let's do 6 here. And let's do...
Define what kind of nuts, please. Macadamia? What are we looking at? Peanuts?
What? Lock nuts. That took me long.
Ah, that's my least favorite ones. They taste like crap.
That took me long to figure out. So I'm anyway. I'm mirroring over this direction. So I'm mirroring something. Oh wait. I need to add. This so the extrude will work. I'm gonna use these lines.
Nicholas is wondering, Martin, could you print both pieces separately and then attach them to the PVC tube to save having to print the tube?
Yes. You mean, for example, like bolting them on or screwing them on or something?
Yeah.
I need... I like those animations though. I think printing the top part is kind of the cool thing here with the construction.
Print a short length and slide the tube in.
That's I think is the correct way to do it. Because then we don't glue where we need the most stability. Where we need the most stability is one single piece. We're gonna mirror over this line. We're gonna mirror these two small little buggers. And now my extrude looks funny. We're going to remove these and we're going to extrude only this. And we're going to... it's not symmetric. Okay, we're going to add and then we're going to fix our mistakes. Merge with this. Merge. Oh, I deselected it. Okay, I see. So we're getting to something a bit sweeter. I also think later we can add some nice brackets. Like almost like a fillet. Like, oh yeah, like that.
Sculpturesque.
Like this. See where we're going with this. This is a lot. It's a lot of stability here. And I think we have a nice print direction like this. Yes, Hannes.
What material are you printing in? Is it still silicone?
No. This is hard.
This is
so
hard.
For the prototype, it's gonna be just the simplest PLA.
Nice. Faster.
But this is not going well because I shouldn't have extruded it like that. I think what I need to do, there's some kind of math that you can't extrude. The reason you can't extrude an end point here because they don't know in the math how to share this point. Derek have explained that to me, so that's why I have to cut off this extrude somewhere before they meet. So if I just I could fix that by making it. Perhaps I should just go a tad larger than the pipe, but I think that's... Oh, but we can go outside the pipe because the plate is... Yeah, we should go outside the pipe because the holders are actually... Let's see how...
Make it bigger and expand the slot outwards.
Yes.
Where are we? Oh, he's back already.
Yeah, I'm back.
I'm switching sounds. There we go.
I realized that I want the width of the holder actually, and then we don't have this issue. So let's go back to this and just see how wide this latest holder is. That's much wider. 47.9. That's annoying. 48 done. Yes, we have all that space. I forgot about that. So this is all wrong. And it's going to be much simpler now. I didn't think this through. I just started. That's fine. That is fine. We're going to do this. We're going to do... Okay, and now I'm going to be good. I'm going to just draw a quarter of this and mirror it in all directions. So we want this to be half of 48.
24.
Yes, I was also proud. I was also proud to know that. And this is 60. Here we go, Hannes. This is vertical. Boom, boom, boom. It added the horizontal constraint there. And then I want a 6mm wall here. Okay. I always need to like start with some bad sketching and then go to some good sketching. I don't know why it's like that. I'm forming a plan while I'm doing it, basically. I guess this should be coincident with this. Is it gonna complain about that? So now it hit this line exactly. Let's do this wall 5mm so it doesn't.
Got a question here, Martin.
Yep.
You never label your parts? Question mark.
Derek has actually said it's kind of professional to save time to not name them when you don't need to.
Okay, and when Derek throws you a bone, you run with it.
Yep, that's exactly. I think now I could use. I wonder if I could. If I could make a. No, let's just mirror.
Ludwig joined the chat as well here. If you end up having to kill this darling, I think I have an idea to make it look much more visual than it is. But you're not gonna like it, so I keep it to myself for now.
Thank you, Ludwig.
Heart.
I think that's a cliffhanger no one wants to have. Tell us the idea, Ludwig.
Is there gonna be lasers and light involved? That's the usual go-to for a lot of people.
Yep.
I immediately see after here. Ludwig, tell us it involves lasers and we'll support your idea.
Okay, I'm gonna add. Yeah, it's if I'm not going to like it, it's probably definitely some kind of RGB LEDs somehow. I guess.
And now chat woke up. Lasers. Lasers.
So here's the first extrude. We're gonna cut this open soon with that first slot, which means that I shouldn't have cut the tube earlier. We can, you know what we can do? If I move that extrude, the cutting, and I say it as I'm a genius, this is CAD kindergarten. Yeah, I move it to the end, we cut through everything. Look at this, look at me go. And I think we want fillets also here. Perhaps not as big as that, but this is structurally really, really, really good, I feel.
You know how good you are at this?
I just mean it starts to look nice. And the fact now that the holder and the tube is one thing is a super positive of this design. We'll see if the resonator sounds horrible. This has missing references. Yeah, we can remove those. I can't remove. What is this? Is some old. It's an old curve. Okay.
My Memplex says the print needs to slide over the PVC tube, so needs to be thick at the bottom as well.
Yep, if we're not going to... Here we're printing the whole thing. I think the sliding is better. So let's...
I am Sam Gibbs from Twitch here. I wish I knew how good Martin is at CAD, but alas, he never mentions it.
Okay, if you get an alas in, a Dumbledore alas, you're going to be featured. It's that's just the rules here. That extrude is deprecated. We have a red sketch regarding how I added some kind of constraint here that broke the sketch. Oh, I fixed it.
And Ludwig is back now. Well, kinda. Laser projectors mapped to the machine with scrim textile so you also can see notes fly out from the machine. Again, I'd probably have to show you to convey the idea. Woo! That sounds sci-fi.
That sounds very sci-fi. Here's another gripe I have with Onshape. I have a line on top of another line. I have this little extra line here that we don't need anymore. Oh, perhaps. And it's hard to get hold of it. It's hard to delete it.
Mm-hmm.
I don't know what I'm doing wrong, but let's see if we remove this constraint. Are there more constraints? I remove this I can leave it in there, but it's a gripe I have. It's hard to choose select other, and then I should select that line. Like what you should do is that you should right click here and select other. And you should get a menu over all the items. But when I now click in this menu, the menu disappears. Oh wait, maybe I should hover over. Can I then see select? I feel super stupid with it. Can I?
You can scroll.
Oh yeah, no, hover over here. That's the key. That little line lights up, and now I can delete it. And the sketch dies. Why is the sketch dying? Was it because of the use? Ah, I know what happens now. We
Ungripe?
yeah. It's I'm happier now. We moved the cutting of the slot, and then the use of the geometry broke. That's all my fault. But now I think if we go like this, everything is fixed. Okay, we have now clean CAD. Great.
Let's see. My memeplex says here, you don't need to print the whole pipe. That wastes time and PLA. 5 centimeter slide room is enough.
Yep.
You need short pipe for highest note anyway.
Very, very good. So let's prepare this for slotting in a PVC pipe rather than printing the whole thing.
Handry says thicker at the bottom and add a chamfer to slide the pipe in more easily.
Yeah, love this feedback from chat here. It's brilliant. I'm just going to remove this, which means that we should actually basically forget about I built this app pretty stupidly then. I think I should not. We should, if we go back, we need to build this up a little bit differently. We need to this extrude should not be an add. This should be a new. And this extrude should also involve. No, we
Heads up to you, Martin. 8-minute warning
Okay.
now.
I think I want to include this in the same extrude. It's still not an add. Aha. Aha. $36.2. We also then need these lines. Boom. Then we're going to extrude the sleeve that the PVC pipe is going to slot into, which is this one. And we're doing that like this. Someone said 4 centimeters. Let's go with 4. So here you can see the PVC pipe is going to slide up exactly until this end here. And this is 40 millimeter, correct. We're still going to do these nice fillets. Oh, sometimes you're lucky. That looks kind of beautiful. That looks like I've been thinking about this.
Yeah, look at that.
Because-
That was the meaning all along.
Perhaps I should do the inside fillets first. Let's go a little bit hard here. 30. Yeah, I like that. That looks beautiful. We have also what extrude is this done? Oh, this extrude is now has to also go on this part. Look at us go, Hannes. Printing direction is this. It's a simple part to print. I so appreciate, like when we were discussing how to try to tell the Mar Machine 3 story and not derail me, we started dreaming about live streaming, me and Hannes. And I think like there's so many advantages. There are some disadvantages. I start playing around and stuff like that. But the live help with the design coming from like my Memeplex and stuff like that, it's so nice to have people to talk to. I think also like for someone like Memeplex, we can also like, I don't know Memeplex, your situation, but we would like to invite people to a voice chat during the live streams in the future. Because then you can actually like, some of you who are really like contributing value, you can like be in the stream, perhaps with voice, perhaps with image if you want to, and actually help me design on the spot. That would be so fun, because then I can get your feedback. I can talk to you like I talk to Hannes, because like it would be also super fun to try. So
yeah, let's work towards that. And right now, my Memeplex is wondering, is the pipe correct diameter internally at the bottom now?
Yep, it's 40, which is the OD of the PVC.
And Handry says chamfer to slide the pipe in.
Will do. Will do.
You have 4 minutes left. You can do it.
We're gonna do, I think what's nice with that chamfer is that we can do it on, not on a 45 degree, we can do it on a, the other way around, we can do it on another degree. We can do it like that, like a really steep one. That looks, I almost made a Swedish swear word. We have the chamfer.
Yeah, I feel like I also want to bring out a Swedish curse word when I see that Nofle has subscribed to tier 1 on Twitch.
Fantastic. Look at this. I mean, it took us some time. We're going to have attachment points here for the silicone holders. I have to figure those out, or perhaps the holders need to figure them out. I think I should add...
Jimmy says, would love to give you stern talkings live.
Jimmy, you are invited. Some stern talking from Jimmy. We're gonna try to see if it's distracting, but yes,
We can see what we can do. My Memeplex says I'm okay with some more direct feedback.
Does that mean what does that mean, my Memeplex? Did that mean that you wanted to be on, or that you didn't want? I could read that to both ways. Oh, I love this. I really love this. I think this is fantastic. I would...
Gilmar Oliveira, you need some tolerance so the tube can slide in.
Hmm. 40. Let's do the printer. It's very exact. Let's take a measurement with the caliper.
And my Memeplex says, yes, I think I can help a bit.
40. That would be so fun, my Memeplex. Would be super fun. So let's... So I wonder for both Jimmy and my Memeplex, what time zones are you in? But you're obviously here on our normal streams.
90-second warning, Martin.
Okay. 90-second warning. Let's beautify the sides of this. Not too much. It's going to be a smaller fillet here.
While you do that, I just want to highlight the wonderful backers.
Fantastic. And also, while you're doing that, I want to talk about something that Derek talked about. For this comment who said that you need some tolerances, Derek says that moving face, it's actually fine. So I can click move face here, and I can move it. I want to move it other way, so I can move it like 0.1 millimeter. Let me just do 2 to make sure it's doing the right thing. The move face in Onshape is fantastic. So I think with the printer, I want this really tight.
Yeah, and I also saw a comment here. It was, my Memeplex says, that's fine, you can sand the PVC.
Yeah. So I think I am going to add 0.1 millimeter, but I do want it to be a tight press fit and without like destroying the 3D prints. I think 0.1 millimeter is a little bit extra room there with a move face command. And then you can actually add, like, even if there's another thing here, you can rename this to move face tolerance press fit. And then what's nice with that is that it keeps your sketches. Sure, it's another feature, but like Derek's masterclass is like, it's nicer to have 40 here in the sketch because it's like what the pipe says. And then you add the tolerances with move faces. I think it's a really nice idea. All right. Let's finish this like we started it, Hannes.
Okay.
Thank you everyone for being here. Do we have the wireless?
We do. Right now we have the wireless. Yes.
Yeah. So we did. I'm really happy for today. We did checkpoint pivot location. We have designed the tube holder 2-in-1. It's missing some screw holes. And then I think I'm going to finish that and start the proto print during lunch. So I didn't get to that. But now in the afternoon stream, I think I'll have this print on the work desk. So yeah, let's... you take us out, Hannes.
Okay. Do we have any wonderful music going?
We have. We will have.
We will have. That's fantastic. So, thank you all for tuning into this stream. It's been lovely being here with you. Hopefully, it's as lovely for your ears as it is for me. That's pretty loud, Martin.